So today we're going to be talking about definite integrals. So in the last video about integration, we talked about indefinite integrals and the geometric visualization of it. So now we're going to talk about definite integrals, right? So just to remind you on the definite integral notation, it is this. As you can see, it has A and B. So those are your values you're going to evaluate the integral of fx of, okay? Alright, so let's go of a more geometric, say, interpretation of this. So I'm just going to draw a little graph right here, like this, right? So this graph's going to be y equals x squared, just for simplicity, just the easiest to know. Alright. So with normal integral, you'd find the area under this curve, but there wouldn't be an end. So, but with a indefinite or definite integral, you'll get an actual value to it. So you're not integrating from whatever, you're integrating from specific points. So let's say you're integrating from right here. Let's call this point A, and A is equal to 1. And then let's call another point here, B, and B is equal to 3. Okay. So what you're doing is you're going to find the area under the curve from A to B. So that's what this notation means right here. Alright, so let's go on solving this y equals x squared, okay, or fx equals x squared. So we're going to write this integral, and then we're going to use the same boundary terms just to make it easier. So A in this case is 1, B is 3, and then x squared dx. Okay. So what we're going to do here is first, we're just going to integrate this normally, any normal person would. Then we're going to plug in the boundary terms, into it, and then we're going to subtract the highest term by the lowest term. Okay? So just integrate this. This would be 1/3 x cubed, because we use power rule. But then we need to evaluate it. 1, 2, 3. So this was what I need. We're going to evaluate this, right? So first we're going to plug in 3 into this. So it'll give us 3 squared, which we get. So 3 squared is 27 over 3. So that's your first part, which that's going to be equal to 9 minus, so we plug in 1 into this, it'll give us 1/3. Okay? So this will be 9 minus 1/3. Alright, so this is equal to 8 2/3. So see how much of a difference this would be, or this is from definite, or from an indefinite integral. See, with indefinite integral, it'd be 1/3 x cubed plus c. Constant is what changes it. But here we have a real answer to y equals, or fx equals x squared, right? So before this video ends, I'm going to go over the definition for the definite integral, because there is a definition for it, similar to the definition of derivative, right? So, and there's a whole proof behind this called the fundamental theorem of calculus, but we're not going to go over in this very easy, simple tutorial. So I'm going to first write down the derivative definition, and then the definite integral definition. So derivative definition, we all know this from my first video, is f prime of x is equal to the limit of delta x approaches 0 of f of x plus delta x minus f of x sum of I to 1 and of f of xi times b minus a over n. Alright, so this would be the definite integral definition, but like the definition of a derivative, it's not the best way of finding a definite integral. It's just there to kind of prove it or define it. So thank you for watching my video. Have a great day.